Hi guys, welcome back. We are going to solve exercise for our lecture number 6. So as you remember that we have gone through several algorithms in this lecture, and we have talked about how we can schedule different processes in a CPU using different techniques, different algorithms. So I have two algorithms over here. So what I'm going to do is I'm going to solve one of them for you, and I'll give you the other one to practice that. So I'll do the first come first serve scheduling algorithm for you, and you can do your priority scheduling algorithm. There are other algorithms as well that you can definitely program. Some of them should already be available on the internet, like round robin is pretty famous. You can find code for that online as well. If you want to try it yourself, please try to do that, but I will leave that to you as well for practice. But before going to round robin, these are few simple algorithms. I think if you try and start from here, it will help you in building up the foundation for round robin as well. So I'm gonna do this for you just to tell you how we can find out the average wait time, for example, and all the information is written over here. So what we have to do is we have to create a first come first serve scheduling algorithm that will take some processes as input, and obviously we can hard code, we can take that from user as well. We take the burst time, obviously. If you remember, we need to know the for first come first serve algorithm, we don't really need the burst time, but it's always a good idea to provide a burst time, and from there we can calculate rest of the times, rest of the things like wait time and response time and so on. So I'm going to take an input of number of processes. I'm going to take an input of burst time as well. Then from burst time we can calculate the wait time. We know how to do that. Then we calculate the turnaround time. So turnaround time is actually burst time plus wait time. If you remember, in one of the slides we mentioned that in order to find out turnaround time, we can just add the burst time and the wait time. And then finally we'll calculate the average time for all the processes. If you want to compare this average wait time of first come first serve with other algorithms, you can definitely do that. Finally output all the details for process number, burst time, wait time. So we have to display all the details in the output. So let's get started. I have my virtual machine up. So what I'm gonna do is I'm gonna save this as maybe first come first serve .c over here. So let's get started. Let's start with including some libraries, some important libraries, like we do always. So let's do that first of all. So stdio is one of them, and let's include stdlib as well, because maybe we can randomly generate process burst time as well. We can input as well, but I'll do randomly. So these are two libraries. Let's start the main method and return 0. So the first thing as per our exercise is take the number of input, take a certain number of processes. So we need to get some processes first of all. So I can take maybe an array. So what I'm gonna do is I'm going to take a constant. I'm sure you guys definitely know about this. You want to do it this way, it's absolutely fine. You want to do it another way around, I'll take 5 processes. So this is I have defined this constant over here, not a constant actually, but just to make sure that I can use this num instead of 5 every time. So I need to get the burst time, I need to get the wait time. Now first of all, burst time. So I'm going to take an array that contains all the processes, burst time of all the processes. So I'll call this burst time, and how many processes I have, I'll go num, because num is the number of processes for me. You can directly type 5 here and remove this line, it's absolutely fine. Then I have to calculate the wait time. Let me initialize this with 0. I want to calculate the turnaround time as well. So I'll do turn around underscore time as well, initialize this with 0 as well. Yeah, that's pretty much it. So let's first of all randomly generate some burst times for the processes. So I'm gonna run a loop. So int I is equal to 0, I is less than num, and I plus plus. You can do whatever way you like it. I'll do it this way. So I'm gonna just generate some burst times, random burst times. You can hard code them as well if you want it, but just wanted to show you how we can generate the random numbers as well. So burst time of process 0, since I is 0 right now, will be, there is a function in C which is called rand, and I want to generate maybe burst time within maybe 10 milliseconds, first 10 numbers. So I'll do that, and let's first see what we have. Let's see, maybe I'll call it, let's call this process, I'll call it maybe process 1. So process 1, let me put a tab here, and let's display the burst underscore time, and let's put a new line maybe and display that way. You can display it any way you like. I'm just gonna do it this way. And there are two variables I'm using, this and since I'm using a tab, I'll use a tab for this one, and I'm gonna do this. And first one is I, since it's process of whatever process it is, and then the second one is burst underscore time of I. And let me display this. Let's see. So let me navigate to, let me increase the size of this thing. Okay, so let me move to the folder and let's compile it. So it's gcc fc, yeah, and fcfs dot o. Alright, we missed a semicolon, which is here. It compiled successfully. Let's see if we got the required output or not. Okay, process and burst time 3, then it's displaying process. Alright, so it's just a little bit messed up, otherwise it's fine. We just need to fix the alignment of this one. So what I can do is I can do something like this. So burst time is fine, and this is fine, and after that I can put maybe a slash n over here as well. Let's see if it works. It's just you can do it any way you like. It's just that I want to fix the output. Yeah, we need to put just few tabs maybe, and it will be fine. So maybe one more tab here just to fix the alignment. Yeah, somewhat there. You can put another tab if you want. It's just fine. I mean, we can do it like that. So this is this. And what else do we want to do? Burst time we have taken. We have to calculate the wait time for each process. Wait time for the first process would be 0, obviously. That's why we started it with 0. Since whenever the first process comes, the wait time of that process will be 0. I just want to go to a particular slide for this one. Yeah, so where was that? Yeah, let's see this. Since the first process is coming over here, the wait time for the first process will be 0, and this is exactly what we want. This is what we did. And for the first process, if you see the output, we have to display the wait time as well. So let's display maybe the wait time as well. So after burst time, let me put wait time here. So I'm gonna do slash t. In fact, don't have to do this here. Slash t, and maybe do a wait time. Yeah, maybe that way, slash on here, and we need to put the wait time here, wait underscore time, Yeah, that should be fine. So let's run this. What happened now? Oh, we missed one of the parameters here, so let's do that. T and ampersand d. Yeah, so let's try again. So the wait time of this obviously is first process, the burst time is 3. It's randomly generated. You can see these are randomly generated between 0 and 10. So 3, 7, 5, 3, so which is good. Wait time of the first process should be 0, which is correct. It's 0, and for rest of them it's showing 0 because we haven't done any calculation yet. We'll fix it in a while. But I mean, it's showing. I mean, it is showing us the output which we were looking for. So this is this. So what we have to do is we need to find the wait time, right? Before we actually find the wait time, I have to go back to the exercise. So we'll find the wait time, and yeah, let's find the wait time maybe. So in order to find the wait time, what we have to do is we have to, let me just reduce the font for this so we are on the same page. Okay, so in order to find the wait time, what I have to do is I have to make sure the wait time, so the first process has a wait time of 0. The wait time of the next process should be, I have to add the run time of the previous process to the wait time of the next process, right? So if this one, process 0, is running for 3 seconds, it means that second process is waiting for 3 seconds, right? Similarly, if we talk about process 2, process 2's wait time will be the burst time of process 1 and process 0, right? So let's do it over here. So what we're gonna do is wait underscore time. I'm just gonna add this to, just gonna add the burst time to it, right? Burst time of the previous process, so burst time of I, and every time I run this, it will be added to the wait time of the previous one and the burst time of the previous one. Let's try and run this. Oh, I always miss the semicolon. Okay, so let's compile this, let's run this, let's see what we have. So now if you see, the wait time of the first process is 0, which is correct. Wait time of the second process is 3, which is actually the burst time of the first process, that is correct. Wait time of process number 2 is the burst time of process 0 and process 1, which is 9, correct. Similarly, process 3 wait time is addition of these 3, right? So that's exactly what we have, and then the addition of all of these will be the wait time of this one, if I'm not wrong. So yeah, I mean, we are getting it right if I'm not wrong. Yeah, all of them is correct. So what we have to do is, so we are done with this one, we are done with the wait time, correct. Now we have to calculate the turnaround time for each process, and we know that turnaround time is wait time plus the burst time, so we just need to add this. So let's do that. So since I want to display the turnaround time, okay, let's see. So turn underscore round time is equal to, as per the formula given in the exercise, burst time of I plus wait time, that is correct. What this will do is it will add the new wait time to this turnaround time. We need it maybe before this. Why? Let me show you why, if I got it correctly. So first thing is, we are not displaying the turnaround time, so let's display the turnaround time first. I will do it here, /t turnaround time and /n. That is correct, that is correct, and that is correct. And let me do double tap here and %d, and let's display here the turnaround time. So turnaround time, let's see what we have now. Okay, so turnaround time for this one should be addition of this, That's exactly what I'm saying, because I'm adding it, so it's not gonna display me this stuff over here. So turnaround of time for this one is should be 9 like this, but it's showing 6 because I am already displaying it over here. So what I have to do is either I do it like this. Let's see. Yeah, even then it will not show. Now the reason is the turnaround time, if you see over here, is the turnaround time, it's not adding them. What it's doing is it's displaying them first and then adding them. So if you see over here, I am displaying it first and then I am adding it. Before this statement, the turnaround time is 0, so it's always displaying 0. So what I can do is I can take this statement before the print statement. So by the time we have print statement, we already have our calculated turnaround time. This is different from wait time, because wait time is adding itself every time, and the wait time of the first process is always 0, which was displayed by this. But turnaround time for the first process should not be 0, right? It should be calculated based on this formula. So let's run it again. Yeah, it looks good now. So burst time plus wait time of process 0 is the turnaround time. Addition of these two is this, last one is this. Perfect. So it's working fine for us. What is happening over here now is, so if first process P0 comes in our queue first, so it will work first. Then process 1 comes, it has to wait for process 0 to complete, and then rest of them. I think we're good. What else we have? Calculate the average wait time. Okay, so we have to calculate the average wait time and then finally output. So we are already outputting this. So in order to calculate the average wait time, we have to maybe take another variable, average underscore wait underscore time, and calculate everything inside this. This is what we can do. So let's do average wait time. So average wait time will be, so average wait time will be outside this loop, because I will add all the waits. Let me go back to slides just quickly to show you. For first come first serve, I don't know if we have taken the average wait time or not. Let's see this process. So we haven't taken the average wait time for this, but let's use this. So average wait time, how to calculate the average wait time is add all the wait times and divide them by the number of processes, right? So let's add all the wait times first. Let's add all the wait times first. This is what we want to do, and then divide it by number of processes. Number of processes we already know there are 5, so we have to calculate the average wait time. So let's add all the average wait times. For that, what I'm going to do is average wait time plus is equal to wait time, right? So all the wait times, so the wait time of the first process, wait time of the first process should be wait time. So average wait time will be 0 plus wait time of the first process, then the next loop the wait time of the second process, right, and so on. So this will contain the addition of all the wait times, right? So outside this loop, once I have the wait time, I will simply display outside the loop the average wait time. I don't have to display the average wait time over here, right, because otherwise it will show another column and start showing me average wait time for all of them. We don't want that. We want the average wait time of the whole algorithm. So this is what I'm going to do. So I will do printf. Oops. Okay, so we have printf over here. Okay, so printf, and I'm just gonna say average wait time, and it will be like this, and avg wait time, and I have to divide it by total number of processes, right? Otherwise I will just get the sum of all of them. So I haven't divided it by the number of, because it's an average, so I have to divide it by the number of processes. So I have this under average wait time, addition of all of them, but I have to divide it by number of processes, right? So I'll just divide it by num, right? And that's pretty much it. Let's see if it works. It's displaying it over here, so let's see what we have. So we need to just calculate all of them, add all of them, and divide it by 5. Okay, so let's do that. Okay, so it's 0 plus 3 plus 9 plus 16 plus 21, oops, 49, oops, 49 divided by 5, 9.8, but we are getting 14 over here. That's wrong. Okay, so what did we do over here? Okay, let's see. So what's going on over here is we have taken that, so this is absolutely fine. There is something wrong, maybe this this statement. So this is the new statement we wrote. So what happens is it starts with 0 plus is equal to the wait time of the first one, which is 3, for example. Okay, so I got it. I got that. So what is happening over here is it's updating this one after taking the wait time. So it's not considering the wait time 0, right? It's so first time the wait time is 0, right? For the first process the wait time is 0, but over here what we are doing is we are updating the wait time and then adding it. So I have to just take it up before this statement. So I have to take it before this statement so that I can get the average wait time, wait time 0 included as well. It should work fine. Yeah, it should work fine now. So let's see, 9. Yeah, that's it. Since I have taken, I think, integer, so okay, so average wait time is integer, that's why it's not showing 9.8, right? Our calculator was showing 9.8. So what I'm going to do is I'm just going to do float for this, and let me do f here so that we get the decimal values as well. So yeah, so we have 9.8, exactly what we have over here, right? This is exactly what we were looking for. And what I'm going to do is I'm just going to put a slash in here also, and I will do a 0.2 decimal places, something like this. So if I do again 9.80, okay, let's put slash in here. Okay, let's do this now. So this is how it looks like, right? So 9.80, and that is exactly what we had. It's just adding all the wait times, dividing it by number of processes, which is 5 in this case, and it displays us something like this. So turnaround time is 3, and then 9, adding these will get us the turnaround time. Wait time will be the burst time of the previous process, so wait time of process number 2 will be the burst time of this process and the wait time of this process, right? Yeah, exactly, and so on and so on. So this is exactly what we wanted. If there is no other requirement, let's see our exercise now. If we have something else, so calculate the average wait time for all the processes. We have done that, so we have found the average wait time of all the processes, which is 9.8. and finally output. So and we have displayed everything, right, along with the output. And yeah, I think we have achieved this task, completed this. So this is how you do it. We can increase the number of this to maybe 9 or whatever, and try it again and see if it works or not. So this will display us for 9 processes starting from 0 to 8. You can make it any way you like, and I think it should be fine. Yeah, so this is how you find it's a very simple algorithm. Didn't take us too much time to develop this. It's a very simple algorithm, and as I said that it's simple to implement. The problem with this one is some processes will take a lot of time to run, and this is the only problem, right? And that problem can be solved by other algorithms we have studied. So try to develop some other algorithms as well. Fortunately, with this topic, we have a lot of algorithms that you can develop your own. I mean, you can practice yourself though developing those algorithms. So I'm not going to develop another one for you. So try to develop this for yourself. It's priority scheduling algorithm. So in this, what you have to do is take a number. So this is same like what we did right now, and this is also the same thing. This is, in fact, it's all very similar. So these 3 things are exactly similar to what we have done over here, so you don't have to do anything else. In fact, this one is also very similar. Calculate the average wait time, Why? I think I just placed exactly similar things over here. Yeah, so what you have to do over here in priority scheduling algorithm, what you have to do is you have to put priority as well, right? So maybe it's the wrong slide. It's just the same. I think I have placed just the same thing, if I'm not wrong. There are a few things different. Anyways, you need to find all these things anyways. But what you have to do is in priority scheduling algorithm, what you have to do is you just need to uh, in fact, let me check. Maybe I have already developed it and I can show you maybe the output, but you have to develop it yourself. So let me see. Maybe I have it already on my system. So, okay, selection number 6. Yeah, so I have it. So what I'm gonna do it, let me run this and see what we have. Okay, so you should have something like this. So we have, so instead of showing all these things, so okay, so what you have to do is you have to take two inputs. First input will be the burst time, which is something like this. You can randomly take that, no problem. The second thing you have to do is you have to randomly put, or maybe you can hard code this. You can randomly put these priorities as well, just like what we had in our slides, if you remember. So you can put these priorities as well, something like this. So you can put these priorities as well. And once you have the priorities, what you have to do is before you actually run all this, something like this, what you have to do is you have to sort the whole thing by priority, right? So if you see, this is before sorting, right? You have to sort it by priority, right? So your whole queue, if you remember, your whole queue will be sorted by priority. So any process that is having high priority should come first here in the queue, then second, then third, and so on. So this is exactly what is happening. So this is the original data, and then you have to sort the data first by its priority, so that process 2 comes first, and then you have to calculate the bus time is already there, priority is already there, so then you have to calculate the wait time and turnaround time, right? So after sorting you will do something like this, and at the end the average wait time, which is pretty similar to what we have done over there. So the only thing you have to change is add a priority column to it, then sort it. I think C language already has a queue sort function, but obviously you are free to develop this program in any of your language, because I'm not using special libraries that are available only in C. It's just a very simple program. You want to run it in C, you want to program it in Java, you want to program it in VB, Python, you are free to do that. Whatever is your favorite programming language, you can program it over there, because we are not doing anything special over here that is not available in any other programming languages. So you are free to develop it in any programming language you want, and you just have to display something like this. I mean, do it something like this. I'm not too sure if this is working fine or not, but of course it should be fine. So try to develop something like this, and in your favorite programming languages. As I said, in C language there is a built-in function for sorting something based on some available things. You can do that. Qsort is the name of that function, if I'm not wrong. But in other programming languages, if you're using Python, I know that you can put everything in a queue, and there is a sort function in Python as well, and you can sort that list according to that sort function, according to whatever you like. There is dictionary also, and you can sort them as well. So there are a lot of functions in Python, built-in functions. You can do that. I'm sure Java already has some sorting functions, so you can try them as well. So try to develop this. It's not a very difficult function. You can add difficulty to it. It's up to you what else you want to calculate, but these are the bare minimum that your function should do. And then later on, if you want to do some more practice, you can go ahead and develop shortest job first as well. There are so many algorithms that we discussed. Round robin is another famous one. I would love to bring that in exam. So it's one of the questions that operating system instructors, they normally bring either in quizzes, assignments, or in exam. I'll see. I don't know. You can find this code online. There are millions of versions of this code, but try to develop it yourself. You can do it. It's not that difficult. You understand how the program works, how the algorithm works. It's all about just putting that into your favorite programming language. So that's pretty much it for this. We have quickly done our exercise, and yeah, that's pretty much it. I'll see you in the next class. As always, if you have any questions, please drop me an email. We'll talk. And if you want to discuss something else, you can join me in my virtual office hours. So thank you very much. Have a nice day. Bye bye.